All right, hi everyone, and welcome to part 2 of our Infrastructure as Code workshop, this one on advanced infrastructure as code. My name is Luke Hoban. I'm going to be walking us through the workshop today. We're going to give folks a few minutes to stream in here, so we'll probably start in about 3 minutes. So first, just to make this a little bit interactive off the gun, want to just sort of ask folks to fill out this poll, so you can respond up here at pollev.com/lukehoban275. And just want to know how many people here attended part 1 of the workshop last week, or checked it out on YouTube, or have generally already used Pulumi a fair bit. All right. Gonna wait for a few more to come in, see how much input we can get here. We'll have a few more of these polls throughout as well, so we'll try to make sure that for folks who do get this set up, it'll be easier to go and answer kind of some of the next polls as well. All right, great. So a decent split. So a lot of folks did attend, so that's good. I'll give a really quick recap of part 1, but I am going to dive into some meaningfully more kind of advanced concepts and material throughout this. So definitely hope that folks have had a chance to check out Bloomie prior to this, and if not, feel free to ask questions as we go, and we'll try and address any topics that you guys want to cover as background. Okay, so just as a recap for last time, I think we talked about a few key things. Oops. I'll get rid of this presentation bar down here. That's right. Okay, so as a recap, we talked about a few key things. So one is we talked about modern infrastructure as code and kind of Pulumi enabling us to do infrastructure as code for the modern cloud, and that being things like containers and serverless and Kubernetes. And not just for the compute parts of that, but for all of the infrastructure we need to develop. So that could be the compute, compute containers, whether it's the VMs or the serverless functions or the container clusters, or it could be the core infrastructure layers, the networking and security that we need to set up, or it could be the data stores, the object stores with S3 that we demoed and walked through in the workshop last time, or RDS databases or what have you. And then finally, kind of the application layer and how do we deploy the application components themselves into that compute. And so Pulumi really, we looked at kind of what that modern infrastructure as code looks like, how that shift into kind of the cloud infrastructure world is impacting the way that we think about needing to use more expressive ways to describe our cloud infrastructure instead of just pointing and clicking or scripting our infrastructure deployments. And part of that was really the idea of kind of enabling developers and infrastructure engineers to collaborate. And so one of the key things with Bloomie is trying to bring those two worlds a bit more together as we move quicker with our infrastructure. We need to have the development and ops teams kind of be working in unison and often actually collaborating together closely. And so one of the things that Pulumi really enables, both with modern infrastructures and with using real programming languages, is a closer ability for development and infrastructure engineers to work together. And then we talked about kind of the sort of key thing that makes Pulumi different than some of the other infrastructure as code tools that folks may have worked with in the past, whether it's CloudFormation or Terraform or Helm YAML in the Kubernetes space. And that is that Pulumi kind of lets you use real programming languages. So it lets you use Python or JavaScript or Go or .NET. And this brings some sort of basic things that are just nice to have, like loops and conditionals and functions and classes. And we saw some of these kind of in the workshop last time. And so if you haven't yet seen that, you can go back and see kind of what it looks like to really use loops, what it looks like to be able to use packages and that sort of thing. But the more important piece there is really that it lets us share and reuse components of infrastructure in the same way that we do when we build application software, instead of just copying and pasting blocks of YAML around all over our code base. And so as things get more complicated, this becomes really important. And then finally, we really emphasized and kind of demoed a lot about how even though we're using these fully expressive programming languages, Pulumi is still a desired state infrastructure as code tool. So the program you write, even though it's imperative, will run to create a desired state, and then the Pulumi engine will drive our infrastructure to that desired state. And this means you kind of get the best of both worlds. You get the expressiveness of real programming languages, plus the desired state declarative model of infrastructure as code. And finally, by using existing languages, we sort of get all these nice, nice benefits around our end-to-end application development lifecycle. So we get IDE support and linters, we get to use test frameworks, we get all of the communities and libraries and packages and things around our language of choice, whether it's Python or JavaScript or what have you. And so we get to bring to bear all these software engineering concepts and use them now in our infrastructure as well as in our application code. So again, if any of this, if any folks are interested in going deep on this or have questions on this, feel free to raise your hand or drop a note and we can answer that now. Otherwise, definitely encourage you to go check out part 1 of the workshop. Okay, so in terms of what we're going to cover today, a couple of key things. So first, we're going to talk about some concepts. So 3 of the sort of more advanced infrastructure as code concepts that I wanted to touch on today were components. And this is really speaking to that point on the last slide about instead of copy pasting, we really want to think about how to create reusable blocks of infrastructure that we can apply throughout our code base and treat like software artifacts, like new APIs and new packages. And so we'll talk a little bit about components and how we can use those. We'll also talk about multi-stack architectures. And so as your infrastructure grows beyond the complexity of just a single single deployment unit, and you want to have multiple different things that are being deployed that are maybe related to each other. How do you think about that? How do you break that up? And how do you structure that within your infrastructure as code? And then finally, we'll, time permitting, we'll touch on kind of testing and how we can apply some testing practices that we might be used to in our existing languages and existing application frameworks, and apply those into our infrastructure as well. In particular, how we can test these components of functionality as we develop them, so we can have confidence that they accomplish what we want them to accomplish. And then we'll get very hands-on and build up some real infrastructure. And this time we're going to move from the very, very simple infrastructure we looked at with just standing up an S3 bucket last time and standing up a couple of EC2 instances. This time we'll stand up a lot more infrastructure. We'll stand up Kubernetes clusters, which involve several different resources all kind of working in interesting ways. And then we'll stand up applications and services running inside those clusters. And so we'll use Pulumi's infrastructure as code for both managing cloud and managing Kubernetes, which is a pattern we've seen. A lot of teams are trying to approach right now. Okay, so I see a question about was the part 1 recorded and is there a link? Yeah, it was recorded. I believe it's up on YouTube, and somebody else who's on the call can probably drop a link in here in parallel to me moving on with the discussion. But definitely encourage folks to check that out as well. We'll make sure the link gets shared here. All right, any other questions before we kind of dive in? Okay, great. I'll keep going then. So the first kind of lab we're going to do, and before I go into any of the sort of conceptual things, just because it's going to take a while to stand up our Kubernetes cluster, I'm going to walk through the first lab here, and then we'll kind of step back and talk a little bit about some of the concepts that we touched on here in a little bit more detail. But just to give ourselves time to deploy this cluster, I'm going to do this. Now, for folks who do want to follow along, this is optional. You don't have to do this if you have access to some existing Kubernetes cluster, whether it's Docker for Desktops Kubernetes cluster or something else you have within your organization. You'll be able to follow along with the next lab where we go and work with Kubernetes resources. But if you don't already have a cluster, feel free to follow along with this lab. So let me go ahead and jump into this lab. And so the lab I'm going to be working through, just for folks who are following along, was linked on that slide as well, but it's in the Plumie Infrastructure as Code workshop on GitHub. And then I'm going to be doing labs, AWS. I'm going to be doing this in TypeScript this time for the first part. I'm going to switch back to Python for the second part. We're going to be doing lab 4, which is about deploying a Kubernetes cluster. So feel free to follow along or just do it yourself afterwards as well. Okay. So let's get started. So I'm just going to start in an empty directory. I'm going to create, ISC2. Oops. And then I'm going to just open up an IDE here so we can start working with this. So first, I'm going to create 2 folders because I'm going to work with a cluster here first, and then we'll go ahead and do the app work later. I'm going to just open up a terminal so I can write some code here. So just as in the last one, I'm going to just do Pulumi new. Actually, I'm going to go in that cluster folder. And I mentioned I'm going to use TypeScript, so I'm going to do AWS TypeScript. I'm going to be working with some AWS TypeScript resources, and this one will be I'm just accepting some of the defaults here, and then I'm going to run this in US West 2, just so it's a little bit quicker for me working here in Seattle. Okay. So we've now got our basic project. We talked through kind of what all these files are last time, so I won't go into too much detail there. But what I will do is kind of start with a clean slate here. And the one thing I'm going to use this time is, as well as using some of the libraries, some of the base libraries, like the AWS library we used last time, I'm also going to use a package we have called Plumie EKS. So I'm going to do npm install Plumie EKS. And this is going to bring down a package that has some additional higher level components that we can use to make it really easy to work with EKS. And so now that I've done that, I can say import star as EKS from Bloomie EKS. And as before, because we're in a real programming language, we can do something like, const cluster. And you can see we get, IntelliSense and IDE support. And if we mistype one of these things, we get squiggles. So all of these sort of IDE features that you'd expect from just using any kind of library we get here. But in this case, we have the ability to create just an EKS cluster. And this cluster involves many different resources in AWS. It involves standing up the cluster itself, some security groups, some node groups, an auto scaling group behind the scenes, so many different things. But we get to just think about it as a very simple abstract concept. We just want an EKS cluster with some high level parameterization. So I'll just call this cluster. You can see there's a bunch of different things I can set on here. And so lots of different capabilities that this component exposes for how I can enable it. But the only one I'm going to set is deploy dashboard false. And that's going to say I don't want a dashboard associated with this. Now, the other thing I can do, as well as creating this component, I can also do sort of my own custom VPC, for example. So I can say, const VPC, this new AWS X. Oops. This is a similar kind of component where I just have a high-level ability to create a VPC. Now I can set some things like, what kind of network, the number of availability zones I want it to be exposed in, what have you. And so each of these will sort of create lots of different resources that capture this higher-level capability to create just a whole VPC that's configured with good defaults, or a whole cluster that's configured with defaults. Keep things simple. I'll just, do it like this. Now I'm going to also just export something as well. So like we saw last time, we can export something from our stack so that it's available to other pieces of code we may run outside of this deployment. And so in particular, the thing I want to export is the Coop config that would let me access this. And so I can say export const Coop config equals cluster.coopconfig. Okay. So this is a very simple program. In fact, I can even get rid of all of these. So it's just 7 lines or so. And now I can come over here and say Plumie up. I'm actually going to make this a lot bigger so we can really see what this looks like. So one of the things we see here is that we're going to get that preview, as we saw before, of all the different resources that are going to be created as part of this deployment. We can see it's actually going to create 28 resources for us. So even though we only wrote, kind of 1 line of code here, effectively, we're going to get all of these different resources. And like I mentioned, that's a whole lot of different things in AWS that enable us to have a working EKS cluster. And so I could go look at the details and understand exactly what all these look like. But one of the real values of doing this is that I don't have to do that. So I can just say, I'm going to go ahead and do that update. And so this is going to go out to AWS and actually provision all of the different resources I need. It's going to do this in parallel where it can. Many of these resources are actually independent. So we're going to go out and deploy all of the resources we need to have kind of a working EKS cluster set up. So that's going to take 10 to 12 minutes. So I'm going to go back and talk about some of the concepts here, and we'll come back and look more at this cluster in a second and start looking at what we ended up creating with this. All right, so let me just talk for a second about kind of components here. So components are really reusable building blocks for cloud infrastructure. And so just like any other API you might use in your language of choice, you frequently don't work with just the OS primitives themselves. You frequently use libraries or packages or things that have been provided by either the designers of the language itself or by third-party package managers, things that you find in PyPy or NPM or what have you. And so most developers are very used to working with abstractions and libraries and things that make it easier to work with the domain they're trying to work with than it would be if they had to drop down to the raw operating system primitives that are available. And so this is the same idea with infrastructure. Plumie wants to provide these components that are higher level for you, like the VPC and the EKS cluster we talked about. but also you, as a developer, have the ability to create your own components. Now, there's a couple of interesting things. These components can end up looking almost identical to a normal resource. So just like you could create a aws.ec2.instance, you can create an aws.x.ec2.vpc. And so these components and custom resources kind of can feel and look very similar. And so you can raise the abstraction level without really changing the way that consumers within your application domain work. And so here, very simple to do that. But when you're using these components, there's a couple of interesting things that are sort of Plumie specific. So one is sometimes, for folks who have used abstractions over cloud infrastructure, you may be wondering, what if that abstraction doesn't accomplish exactly what I want? What if there's one little knob somewhere on one of those sub-resources that I want to tweak in a way which isn't supported by that library? And this is something that's sort of more true with infrastructure, we've found, than it is with many other things in kind of application development. And so we have tools, for example, transformations, which would let you say, I want to use this component, but I want to make a few edits to its behavior, kind of like aspect-oriented programming or something. And this, we found, is a nice escape hatch, lets you make sure that any component you use, even if you need to use something slightly different, you don't have to go and fork that whole component and copy its whole code base into yours. You can still just use the component reliably and tweak it if you want to. Similarly, if you're trying to refactor, from a component or from just raw resources you have into a component, you've decided that there's a group of things you've got that you now want to call a component, or you've taken a component and you've decided, hey, I actually want to manage those resources myself. How can you refactor your code reliably? This is also sort of interestingly, kind of different in the infrastructure world, where we have to make sure not just that the code does the same thing, but that the identities of the different resources involved are the same. And so we have this ability called aliases, which lets you do that as well. So very easy to tweak things and override and refactor and those kind of things. So all the patterns that you expect from kind of software hygiene and software development, we can bring to bear on our infrastructure here. And then, of course, as we highlighted, I think in some of the last kind of demo there, we can use off-the-shelf libraries like Plumie AWSX, like Plumie EKS, Plumie KX. We have a handful of these libraries that we've provided. There's some that are out there in the community that third parties have provided. And then we found that many teams who we talked to about their use of Pulumi are actually building their own. And so they love seeing that we have the AWSX library, but the library they want to use for their internal deployments actually has some other custom things that are related to their teams or their organization's best practices. And so they want to have those components that they provide to use within the organization. So that ability to create your own components, I think, is really the thing which makes this particularly exciting. In terms of writing your own components, we have an example just over here. I'll probably show an example of this live a little bit later. But it's very easy. It's just a class, just a component in your programming language. So my component extends a component resource, and then just basically takes three things: a name, the arguments, and the options, and calls a super call, which actually constructs that. And then within its body, you can just create any children it wants, child resources like this one, and assign them to children itself. So just like you'd expect effectively from a kind of any one of these programming languages, and sort of a class-based API design. Okay, so that's a little bit about components. I'll pause here just a second. I suspect my deployment's still not done, so I'll answer any questions that folks have now before we move on. All right. No questions? Going once? Going twice? Okay, I see a question. What's Plumi's story for configuration? And then is the AWS TS EC2 provisioner still the best way to set up post-provisioning? So yes, I think the question here is about provisioning, in-guest provisioning for VMs in particular. So if I have a VM-based setup, how do I go in and run some configuration scripts, whether it's some bash scripts or some Ansible or some Chef or Puppet or what have you. And yeah, so Plumie today, I think in the first demo here, we showed kind of using user data to bootstrap, and that's one thing that you can do today. The example that the person who asked the question linked to is an approach where you can use a feature in Plumie called dynamic providers to build the ability to do that provisioning and SSHing into the instance and all that yourself. And so that's a very flexible mechanism for kind of doing any custom code that you want in the lifecycle of the deployments. But it's something actually that we're also looking at over the next few months. We are It's an area we plan on investing more in to provide some first-class capabilities around injecting code into that lifecycle, especially for the use case of kicking off provisioning scripts related to EC2 instances. Now, one thing there I'd say is also that for some of the modern cloud workloads, like with Kubernetes, which we're going to be spending some time with today, or with serverless, that kind of post-provisioning tends to not be as important, because the cloud resources themselves manage that provisioning lifecycle, whether it's booting up the container or deploying the packaging around the serverless thing. And so we find this is a really important use case for kind of the EC2 and the instance provisioning. As folks move into some of the other places here, we found that those concepts, the provisioning piece is not as important. But at the same time, the broader idea of being able to inject code in the lifecycle is really, as a general capability, that we're very excited about investing more in with Bloomie in the coming months. So great question. Okay, so let's keep going. Let's go jump back to our code, see where we're at. Okay, so it's still creating. So just to not slow ourselves down, I'm going to jump into another cluster which I have, and we'll use that one to kind of show off some of the aspects of what we're doing here. So let me just open up this window over here. Okay. So this one is a cluster that's already been stood up. You'll see it's similar to what I just demoed, except I created my own VPC and set up passed in some of the outputs of that VPC to the cluster. So a little bit more configuration, but effectively the same thing. And I'll show a couple of things here. So the first is, whenever I type Plumie stack, as we showed last time, I can get this link into the Plumie console to kind of get a view of what this looks like, what all the details are here. And so I can see, for example, here's my kube config file. Here's the settings I provided on this. But what's really interesting is I can see all the resources under management here. So I can see that there's quite a few resources in AWS and even a few in Kubernetes itself that are being managed here. So for example, if I look for the config map, this is actually a Kubernetes resource, not a AWS resource. And so we're actually managing both Kubernetes and AWS resources within the same deployment here. I can also see sort of a visualization to kind of get a better bird's eye view of this. And so I can see in this case, if I zoom out a bit, there's sort of two key things. There's a cluster, which is that EKS cluster I created, and there's a VPC, which is that VPC I created. And I can also kind of come over here and see some of the shape of this. So that VPC itself, it was a component, but it also had a bunch of components that it's built out of. And so this allows us to sort of nest how we reuse infrastructure components. And so we only had to kind of create this way of building subnets once in our code, and then we applied it 4 times to build the 4 different subnets here. So we're seeing reuse at many different levels here, and kind of that software engineering concepts being applied. But this gives us a view of all the resources that are kind of currently deployed as part of the stack. And as we saw here, we could even dive into AWS to go look at some of these resources and see what they look like. But what we're going to do now is we're going to say Plumie stack output kubeconfig. And you see what that's going to give us is a kubeconfig for this cluster. And so I'm going to go ahead and take that and say kubeconfig.json. Actually, I'm going to say // And so now I've put that into a kubeconfig file. Here we go. And now I can use that to query what's actually in my cluster. So I can do export kubeconfig. Okay. And so now if I run kubectl cluster info, I can actually see what Kubernetes thinks is actually running inside this cluster that I stood up. And so I'm kind of dropping back into some of my operational tools here because I've done the deployment with Pulumi, but I'm using kube control to kind of go and look at what's running inside this cluster. And indeed, we can see we're connected to that cluster running an EKS in the Oregon region, and that we have some of this running. And we can also go look at sort of what's going on inside this. So we can say kubectl get nodes to see that we have 2 EC2 nodes running inside this cluster. Also get pods-a to get all the pods running. And so we have a bunch of systems components running inside this cluster, the nodes themselves, CoreDNS and Coop proxy. And so a lot of these resources were already running in Bootstrap as part of this. It turns out this cluster, I already had some app deployed into it. So you also see that running here. That wouldn't be in my new cluster I just spun up, but we will run an app inside this cluster very soon here. All right. So that's it for standing up a cluster and kind of what we can get in terms of how the cluster works. So the key things there are really, because we have the components here, very, very simple to stand these up. We can make that process of standing up a cluster just effectively one line of code. But as we need more complexity, as we need to tweak more of the settings, we can both do that using parameterization of the cluster itself here, or by dropping into the raw AWS concepts, tweaking those, working with those directly. So, great. All right, okay, so some people already started answering the next question. So for the next topic, I kind of wanted to go into multi-stack architectures, and we'll kind of see how that relates to the demos we're doing here in a second. But curious if folks want to jump in. I think a few folks joined since our last poll, so if you haven't yet, go to pollev.com/lukehoban275, and you can vote on this poll. I'm kind of just curious, how many independent cloud infrastructure deployments do you have? Both either you or your organization. No one's yet said thousands. That's probably good. All right, give folks just a couple of minutes. See what kind of answers we get here. All right, great. So a decent mix over the different kind of scales involved here. In fact, now, wow, perfect mix. That's good. And somebody does have thousands. Great. So yeah, so it's sort of an interesting thing that the number of different independent cloud infrastructure deployments can vary a lot between different organizations, and even for the same total amount of complexity, there's lots of different ways you can break that complexity up between, kind of the monolithic deployments that you might do, and kind of a microservices kind of deployments. And so at Plumie, we have good support for kind of any of the different structures you may want to use there. Let me talk a little bit about how some of those work. So the key thing that we sort of think of, and when we talk to folks who are doing Plumie deployments, is that it makes sense to break up infrastructure into multiple different stacks where the infrastructure really versions independently. And so infrastructure can version independently for a few reasons. One, just because it fundamentally changes at a very different pace than another set of infrastructure. So for example, your core security primitives for your AWS accounts probably don't change very often, but your application infrastructure might change very often. In fact, if you're doing serverless, you might be changing your infrastructure every time you want to deploy a new version of your function. And so you may actually be churning that multiple times a day or even multiple times an hour. And so there's very different rates of iteration there. And you may want to separate those things just because they're deploying and versioning at a different rate. Another reason why things can version differently is just because they're owned by different teams. So if you have two independently operating parts of your organization, they may want to independently own and version and drive the lifecycle of their infrastructure deployments. So the application development team may want to deploy infrastructure related to the application with a lifecycle that matches the application's deployments, whereas the core platform or infrastructure team may want to deploy things with a lifecycle that matches the sort of cadence of delivery for the platform itself. And so there's lots of good reasons to break things up and draw boundaries where it makes sense based on organizational or velocity kind of reasons within deployment. But I'd say there's a couple of best practices we see. So first is starting with one stack or few stacks. Generally, if you don't have a good reason to have multiple, starting with fewer is always going to be a bit easier because for all the same reasons that having fewer things is easier generally. It just means you don't have to define the boundaries and the interfaces between layers as cleanly and as crisply until you've discovered what the right boundaries really are, what APIs should be on those boundaries. But once you do discover those boundaries, then you can start breaking up and building the contracts for what are the outputs from this layer and what are the inputs from this layer, and how can I minimally couple those two things together to achieve what I want to achieve. The next thing is really the idea of stack references. So Plumie kind of has first-class support for this idea of breaking up your infrastructure into multiple stacks, and that's this notion of stack references. So from a higher level stack, like an application deployment stack, you can refer to the outputs of a lower level stack. So we've been using exports and outputs here in all the demos that we've done, both last time and so far today. And those outputs were useful for being able to script against the stack. So we're able to do Plumie stack output kube config or Plumie stack output URL and use that to build scripts that work with things. But the other reason they're really useful is because they give us access to the outputs for other stacks that may want to build on top of this. And so by exporting the Coop config from our Kubernetes cluster stack, we're now able to build new stacks that use that Coop config and reference the underlying stack. And so if there are changes to that stack, those changes will get picked up in the higher level application deployments as well. The other key thing here is that while Plumie has really great support for this when both layers are Plumie, there are actually also ways to do this when one or both layers is in another system. So when another layer is in CloudFormation or in Azure Resource Manager or in Terraform, you can still actually refer to those resources in those external systems. So maybe you've already deployed your VPC and networking layer using CloudFormation, and you just want to build your application layer using Bloomie. Well, you can just reference the resources that are exported from a CloudFormation stack and use those. And so you can still draw a line in your infrastructure and bring Pulumi in just for the piece where it might make the most sense and where you don't have to go and rewrite a bunch of existing infrastructure and do all that work up front. So very easy to coexist with some of those tools as well and draw boundaries between these components, even when it crosses different infrastructure as code tools. And one of the sort of general guides I kind of have around this is a lot of the themes here are very similar to kind of the monoliths versus microservices debate or lines of thinking in how people think about service architectures. So just like monoliths can be a lot simpler, so can sort of monolithic stacks and single deployments. But just like microservices can make sense once you have multiple independently operating teams and you want to define clear contracts between them, similarly with Pulumi and with infrastructure, it can make a lot of sense to do that as your needs evolve. And finally, we have this sort of diagram in the bottom. I won't go through this in too much detail, but just to give a sense that, in a typical architecture we might have, we're going to kind of maybe have one organization that's working with our infrastructure. And that organization may have multiple projects. And so, for instance, it might have our core identity layer. It might have a core cluster kind of layer. Then it might have various application layers. And so we have each of these three layers as independent projects, which are different code bases, which evolve at different paces. But then for each of those, we might have different environments. So these would each be different stacks. We'd have a dev environment for our identity stack. We'd have a dev environment for our cluster stack. And we'd have a dev environment for our app stack. And we might have a prod environment as well. So Pulumi really supports this idea of both projects and stacks and a matrix between them. So in this case, I'd end up having 6 different deployments, which might all be driven through my CI/CD process or whatever. But I can use those stack references. You'll see these lines between the layers here are actually me using stack references to refer to other pieces of code. Okay, so before I dive into the demo of this, I see there's one more question. If folks have more questions as well, feel free to dump those in right now and I'll address them. But let me answer the one question that we've got here. So the question was, does Pulumi support policies on stack output changes? We found stack references itself is not good enough since it does not enforce deployment order in multiple stacks. Sometimes we only have backward compatible changes, but sometimes the change is special and requires multiple stacks to be deployed in specific order. Yeah, so this is a really great question, and it's true today. Stack references, when you do have to still coordinate the deployments, such that you have compatibility between layers if you've built a stack reference. We have several things we do want to do here. I think there's a lot of interesting things we can do as folks build more and more complex multi-stack architectures with Pulumi. We can imagine supporting sort of orchestration of deployments across stacks, so that if you update something in a lower level stack, which is going to cause some resource to get replaced, then we can cause that replace to cascade through to the higher level stacks and then ultimately back into the lower level stack. And so we see a lot of opportunity to do even richer things around orchestration here with Pulumi, because we do have such a good understanding of all the different layers here. But it is true today that if you need to make breaking changes in a lower level stack, you will have to coordinate that just like you would in a sort of microservices deployment. If you want to make breaking changes in a service that you're running in your microservices world, you do have to do those in staged ways where you introduce the new capability in parallel, adopt it into other parts of your service infrastructure, and then only when the other services that are running within your service infrastructure have adapted to that change do you take away the previous capability. And so Bloomie provides lots of tools for doing that, but it definitely is more work, and this is one of the reasons why kind of multi-stack architectures do require a little bit more work and a little more effort, because they do require you to think about those contracts you've created between different layers. And like I said, I think it's something where we think Pulumi has a lot of opportunity to keep going further here and enabling even richer things in this life cycle. Great. I think that's all the questions I see right now, so I'll keep moving here. Okay. Come back to that question in just a second, but Okay, so what we're going to do now is going to create another. Let's just see. Okay, perfect. So our previous stack that we had did deploy. I'll also go and show this as well, just to show you the new stack as well. So this one has slightly fewer resources because it doesn't have that VPC. Took 14 minutes ultimately to deploy it, and we can see all the different resources involved here. We'll see it doesn't have that VPC component in, so a little bit simpler. But still a lot of capabilities inside here. Okay, so now we have the cluster. Let's go ahead and actually, first, let me go ahead and do some of the same things we did at the end of the last time, just so we're able to use this stack. So we're going to say Bloomie stack. Got that kube config. Put it down here, and then we'll export. I'll just make sure I've got that set up right. Okay. Not sure why that isn't working correctly. Because I typed it wrong. Yeah. That makes sense. So it was. Let's go back to this. Let me just do this again. Plumie stack output kube config. Okay. Now, let's make sure I can connect to this thing. Perfect. Okay. Sorry about that. But yeah, now we got it working. So we're connected to our new cluster over here, and so we'll use this for our next part of our demo. So let me just bump out of here and make their app. What I'm now going to do is actually go through another part of the workshop. So let me bring that up here. Okay, so we're going to go through now deploying containers to Kubernetes cluster. And so again, you can do this in any Plumie supported language. So you can do this in Python or TypeScript or Go or .NET. And so we got labs, AWS, Python, and Lab 05. And so I'm going to walk through this and kind of show you how to deploy some Kubernetes resources into our cluster. Okay, so as before, I'm going to go ahead and say Plumie new. This time I'm going to do Python, and I'm going to do Kubernetes. So I'm going to go ahead and click that, and I'm going to say, Okay. So just to make this a little easier, I'm actually going to create a new window that's just opened here. That'll let VS Code give me a little bit more room, and I'm going to do these same 3 commands that I suggested. So I'm going to create the virtual environment, activate it, and install those dependencies. Okay, so there we go. And let me just pick the local virtual environment so we get all the kind of tooling and things from Visual Studio Code here. Okay, so we've set up our basic Python project now to deploy things to Kubernetes. And so just like we can deploy resources to AWS and Azure and GCP and our cloud providers, we can do the same for deploying into Kubernetes. And so we can connect to any Kubernetes cluster we want and deploy resources into that. So let me go ahead and do a couple of things here. So I'm going to say from Pulumi import. I need a couple of things. I'm going to import export, stack reference, output, and resource options. These are a few things that I'm going to use throughout here. And then we also have the Plumie Kubernetes library, so I can import provider. And finally, I'm just going to import Pulumi itself so I can use things there. And so one of the things you'll note is that I can, well, actually just do Plumie Kubernetes as well. So one of the things you notice is I can do, all the different things, all the different APIs I might expect from within Kubernetes. And so if I'm used to kubernetes.core.v1. pod, for example, every different API that's available as part of Kubernetes is available within Pulumi inside my programming language. And so here, pods or services or config maps or anything I might want to use is available to me to work with within Bloomie. And just in the same way that we project the entire surface area of AWS, we project the entire surface area of the Kubernetes API. So I can work with resources here. The first thing I want to do, though, is instead of me dealing with that, I created that kubeconfig file in my local file system, but I don't want to have to dump that out to the file system, figure out how to get it back in here. So what I want to instead do is use that stack reference capability that we just talked about in the previous slide. And so to do that, I'm going to do a couple of things. Actually, I'm just going to make this a little bit simpler than what if folks are doing the workshop walkthrough. They can do the full thing there. But I'm going to do something very simple. I'm just going to say infra equals stack reference. And stack reference lets me point at some stack that I have. And so in my case, I want to point at the stack that had all those other resources. And so I can come over here. Let me go back into the cluster and just see what its name was. So you see its name was lukehoven/cluster/isc/dev. So this is the organization, the project name, and then the stack, so the instance of that. So if I grab all that and just put it in here, now I can say, kubeconfig equals infra dot, and now I can get an output from that stack. And so here I know that the output was called kubeconfig. And now it turns out that kubeconfig is actually a JSON object. And so what I need is a string. And so I'm just going to use apply, which we talked about last time, to take that config file and JSON.dump it. Okay, so now I've got my kubeconfig as a string. And now I can do a set of variable, which lets me talk to this Kubernetes provider. Like I said, Kubernetes KDS provider equals provider. And now I'll just give it a name. And I can set the kubeconfig to that kubeconfig. Okay, so what this has done is actually I've configured my Kubernetes provider here to talk not to whatever is ambiently set up as my Kubernetes environment, but to actually configure it dynamically. So based on some inputs that I captured programmatically. And this is a key thing. We can use this with anything. We can use this with AWS, with Azure, if we want to, from a single program, deploy into multiple different AWS accounts, for example, or multiple different AWS regions. We can use the same ability to use a provider instance to construct programmatically a way to talk to a particular account or use a particular set of credentials. But here we're using it to programmatically, based on the output of this stack, figure out which Kubernetes cluster we want to talk to. Okay, so now let's at least create one resource just so we can finally deploy something into our cluster. And actually, let me just write this all out. I'm going to say Bloomie Kubernetes. Well, actually, I'll just go ahead these up here. From Bloomie Kubernetes.apps.v1, import deployment. And from core.v1, I want to import service and namespace. So folks, you're free in whatever language you're using to use kind of whatever style you want here. You can type them all out every time, or you can kind of do these named imports. But just to keep the code a little simpler, I'll just do it like this. So we'll just create a namespace. Oops. We'll call it app namespace. Then we're going to set a couple of standard Kubernetes properties on this. So first off, we're going to set the metadata to be equal to name Kubernetes. And then we're going to set opts. And so opts is something we touched on briefly in the last session. This lets us set sort of general options we want to configure our cluster with. And so in this case, we're going to set the provider option, and we're going to use that provider that we created. So what that means is don't deploy this with the ambiently available provider. Instead, use this specific provider to deploy that resource. Okay, so let's try ahead and go ahead and deploy this just to make sure things are kind of working correctly. And what we should see is that this actually deploys a, oops, I didn't import JSON. You see we got JSON is not defined, so let me import JSON. Not sure why my linter didn't catch that, but okay, we picked up too recent of a thing. I'm not sure where that problem is actually coming from. me just try one thing real quick here. Actually, just to make this a little simpler, I'm going to go back to a variant of this that we have here that has this filled out a little bit more and has this set up as I would sort of expect. So let me open this up. That's not the limit. All right. Let me start with this one, which has which I set up beforehand and has the environment set up correctly. So okay, so I'm going to create a new stack here, and then we'll just take that code that we were working with there, and we'll bring that over here. Okay, so let's try this again. We'll just do Plumie up. Okay, great. So we see a couple of things here. So we see that we're creating that Kubernetes Provider. So this is the Bloomie Provider Kubernetes, which knows how to connect to this cluster we've got. And we've got the namespace. And so if we go look at this as well, we can see that we ended up using that provider, used that kube config that we specified. So it got that from the other stack's output and is using it here. And then the namespace here is being created, and it has that name that I specified. It's being created with that provider that we asked for. And so if I say yes, this should actually go and deploy that into a Kubernetes cluster. Okay. Look at what namespaces are deployed in our cluster, but I'll skip doing that for now, just so we can keep moving. Okay, so now I'll go quick through this. For folks who know Kubernetes well, this should look very familiar. For folks who haven't worked with Kubernetes as much, definitely feel free to kind of go and spend time looking through all this. But we can start doing a few more things now. So we can create a deployment object as well. And so in Kubernetes, we use deployments to sort of a key way to deploy a set of pods out into Kubernetes. In this case, I can specify all the exact same things I would expect from the Kubernetes API. I can provide the image, I can provide the labels, that sort of thing. You'll see a couple of kind of nice things that are Pulumi specific here, though. Instead of doing just raw and YAML, we can do things like we can refer to the namespace's name. So we've created this namespace object. Instead of just embedding a magic string all over the place and making sure that string is the same everywhere, we can actually say, hey, this namespace I created, just grab whatever name we used for that namespace, refer to it by object reference, and embed that namespace in here. So if we want to change this namespace later, everything else will get fixed up kind of automatically. Similarly, just very simple things like we have some labels here that we're going to replicate a bunch of times. And so we can just create a variable that has those labels and then use that in each of the places. So we can reduce some simple boilerplate there. As well as deployment, I'm going to go ahead and create a service as well. And this will give me an exposed endpoint for this. And so we're going to map port 8080 in that container image to port 80 on a load balancer. So again, just some standard kind of Kubernetes-isms. And then the very last thing, as with all these stacks, we kind of want to export some an endpoint. And so in this case, this service has a HTTP endpoint that it exposes. And so we'll just go ahead and get that. And so again, we can read off of the service, its status and the load balancer and ingress and the hostname. All these are things that Kubernetes provides as outputs on its resources. We can go ahead and grab that host name and port as the outputs and then construct a URL to access those. So let me go ahead and run Plumie up again. Oh, I didn't save my program. Let me run Plumie up again. Okay, and so here we see again 3 unchanged. So those existing resources, the namespace and what have you, don't have to change. But our service and deployment are now going to get created using all those settings that we provide. So one of the nice things actually with Kubernetes that we didn't see with AWS is actually you'll notice that as these things are deploying, we get sort of a rich status updates on what's going on. And so that deployment, you saw that it was actually waiting for it to roll out the deployment, and the service was saying, hey, I'm waiting for there to be pods to redirect traffic to. And so Plumie actually has baked into it not just the ability to deploy resources to Kubernetes, but also to understand when those resources are ready. And so it will wait for the deployment to complete and only indicate that it's completed successfully when those resources have met a set of readiness criteria that are defined by Bloomie. And this is a really valuable thing because it means we can do orchestration of different pieces of our infrastructure even at the Kubernetes layer, using a notion of kind of doneness, like when is this available, so that we can then go and script some other piece of infrastructure that depends on it. So it's a really kind of handy thing to have. Now, unfortunately, there's one thing when we're running these things in AWS, it does take Kubernetes a while. It says that the load balancer is fully done, but sometimes the load balancer in AWS itself is not done. So it's going to take a second for this endpoint to actually be available. But we'll wait for that to be available and come back and check on it in a second. So before I do, let me just see if there's any questions on what we've covered so far. If anyone does have more questions, feel free to drop them. I see there's one more here. I'll take a look at that one and answer it right now. So isn't there a better way to get the kube config into the file system? So you're kind of you have a lot of different options for how to do this. So your program itself could actually, instead of using a stack export, it could write the kube config to the file system. It could even emit out a bash script that you can run locally to set the kube config and run kube control. But as we saw kind of in the demo, I'd say an even better thing to do is actually use stack references. So you don't have to even have it on the file system at all if you don't want to. All of your Pulumi deployments can work through real objects and real references, and not have to manage it through the file system or through any environment variables. Great. All right. Any other questions before we keep moving here? Nope. Okay. Yeah, so we see here that now this is running. So a very simple little image that says "Hello Kubernetes Bootcamp." So we've got now a load balanced container running inside Kubernetes. So I see a question about what about OpenShift? So I mean OpenShift I think kind of has Kubernetes in the core and then a bunch of pieces on top of that. Those pieces tend to be described by Kubernetes CRDs, and so Plumie lets you work with CRDs. You can use the Pulumi I think it's custom resource is what it's called inside the Kubernetes API. Now, to get really strongly typed support for those in the same way that you kind of get the rich experience that I got to come over here and look at my service. You notice I had sort of metadata and spec, and I kind of get strong typing over some of this stuff. For those CRDs, you're not going to by default get those because Pulumi doesn't know what all the different resources are. But you can build those layers yourself, so you can easily build your own wrapper around the custom resource that has a strongly typed API for either some of the CRDs in OpenShift or with whatever other kind of platform as a service offering you might be using or building on top of Kubernetes. So definitely you can kind of get both there. You can get the raw access to work with those CRDs and deploy, and so you can deploy into OpenShift. But if you want that really rich experience, you'll kind of want to build a little layer on top that projects a nice API like this. Okay, so this was deployed. So let's go ahead and try to make a change and kind of see what that looks like. So the change we're going to make, we're going to make two changes actually. So the first is this one we deployed one replica, so we're going to change it to 3. And then the second one is we're going to change the image that we use. And so let me just grab a new image to deploy into this cluster. So we'll go ahead and just do that right there. Okay, so now if we run Plumie up, we'll again see that Plumie gives us, even for Kubernetes, it gives us the ability to sort of see what's going to change. And so this deployment is going to change and the spec is changed. We can look at the details of that. And you can see those two changes we expect. The replica is changing from 1 to 3, and the image changing from this Kubernetes Bootcamp v1 to this Kubernetes Bootcamp v2. So I go ahead and say yes. And again, we'll sort of see some status for what happens as we're making this change. So we'll see it's waiting for the replica set to be marked as ready. In fact, if we come over here and kind of start refreshing, looks like we haven't yet rolled out the new ones. Okay, the deployment is done. Let me actually try and curl that endpoint, maybe that we're getting some browser caching here. Okay, there we go. Yeah, so we got v equals 2 now. Let me see if our browser is now doing this. No, still getting some browser caching there. So we can see that now we're hitting that second instance of this that was running. So we did update our deployment. We can even do something like write a for loop here. We'll see that they're all running v2 now. In fact, that we're seeing them running on different pods. And so because we scaled this out to 3 pods, we're now seeing 3. We should be seeing, I guess we're only seeing 2 here for some reason, but oh no, there's the third. So the internal Kubernetes kind of load balancing is spreading that load between the 3 different instances of this pod that are running. Okay. So that was doing an update to our Plumie Kubernetes infrastructure, and we could do that. We could do that to update to new versions of our app. We could do that to change things in our configuration, to add config maps, to add environment variables, anything we wanted to do there. Okay, so I see one other question. I'll just go ahead and answer that. So the question was, how are errors meant to be handled with Pulumi during incremental changes to a given stack? So yeah, so it's a reasonably expected thing that as you're making changes to your infrastructure, you'll try to make a change that isn't possible, either because you made a mistake or because something went wrong in the cloud provider. And those are kind of expected things. Sort of failure is part of the development process here. And so the Pulumi deployment will fail as soon as it sees any problem, as soon as the cloud provider says it's not able to accomplish what you asked for. Pulumi will fail the deployment, and it will recognize what has been changed so far and record that, so that when you try and make a change to now your specification and deploy that, we'll actually start from where we left off. So all the changes that you had already made will still be there. If you do want to kind of roll back yourself, you can change back your code to the state it was in before and deploy again, and that will drive back from the partially deployed state you were in to the state you were in beforehand. But generally, if you have a failure, we're going to stop the deployment there. We're going to report the error back to you that we got from the cloud provider, and you're going to be able to make the changes you need to go and do that. So the next question is actually about integration testing. So give me 1 second, and then in the next section, I'm going to be talking a little bit about testing. So I'll address that as part of looking more broadly at testing. Okay. Great, so there we go. So we've built some infrastructure and deployed that. So let's jump back into slides and talk a little bit about testing. Okay. Okay, good. So some folks already started answering this question. So before we dive into kind of Pulumi's testing, kind of curious, how many folks are testing their infrastructure's code today? I'm actually super impressed that so many people are saying yes on this. Let's give it a second to see. All right, yeah. So testing with infrastructure is something I think if my question had been who wants to be testing their infrastructure, I think everyone would have said yes. I think in general, when we see something as complex and as important as our cloud infrastructure, we immediately think, hey, how can I sort of inject quality and assurances into my infrastructure deployments and sort of front load any risk associated with those things? And so I might say, hey, our testing this is really valuable. Today, though, it's hard, right? It's hard to test our infrastructure. It's not quite, it doesn't feel quite the same as our application software in terms of what are the tools available to us to test this. And so let's kind of look at kind of how what Pulumi can offer to kind of help with that. So when we think about testing in Pulumi and really with infrastructure as code generally, I think we think of kind of 3 categories of testing. And really there's sort of a continuum. There's lots of different things folks can do. But I like to think about it with sort of 3 different areas that are worth thinking about as you plan out how can you test the infrastructure that you're building. So the first is unit testing. And unit testing kind of in all kinds of application development is really valuable in large part because it's very focused, very fast, very targeted. And so we can write a lot of tests. We can do kind of sort of TDD kind of things with our testing approach here. We can validate very fine-grained criteria, and we can write a lot of tests that run very quickly and gain that validation. So we can do that in the inner loop of our development. Just as we're typing our code, we can be testing in the background if we want, right? So unit testing can be really valuable. And so the question is sort of how do I unit test and what kind of unit test around my infrastructure? And the key thing to enable us to make that kind of testing fast is, of course, we can test the logic of our Pulumi applications, but we can't test the cloud providers themselves because it's going to take minutes or minutes or longer to deploy a whole set of infrastructure. And so when we think about unit tests, we really think about what can we do to mock out the infrastructure we're actually deploying and just validate that the code we've written, the imperative code we've written, is correct and is doing what we want. And this is particularly important when we think about these components. So we've talked in the previous section about building these reusable components like EKS and like the VPC component. And having tests that validate that all the different logic about how we're wiring up pieces of that component is being done correctly, so we can gain confidence in the correctness of the component is really valuable, right? And we can actually do that using these unit tests without having to actually deploy a whole sense of infrastructure every time we want to run our validation. And so now we really can have these tests just running in a background worker and reporting anytime we fail. And so we can use all of our sort of standard test practices to get this really fast in the loop of kind of unit testing and application development. But that, of course, isn't going to test everything, right? That's just going to test the logic of our Plumie code. It's not going to test whether that logic was the correct way of configuring those resources in AWS or Kubernetes. And so we do need to actually validate things about the resources we're really creating. And so that's where the next two categories come in. So the first of those is sort of property tests, which really run resource level assertions while the infrastructure is being provisioned. So you can think of these as sort of policies where I have things that I want to be true about my infrastructure that I don't want to get violated. I want to make sure that certain ports are not opened up on any of my load balancers, that no instance is directly exposed to the internet, that the only things exposed to the internet are my load balancers or my DNS records or whatever. And so I can set all these things up as policies that I enforce, and I can then run those as sort of resource level assertions during the deployment process. Anytime I deploy my resources, I'm going to run a bunch of tests right before I deploy it to catch that it is not violating those. And so this is a nice way to just ensure confidence and ensure compliance criteria. There's a sort of, Bloomie has this thing called policy as code that lets us actually write in our programming languages, in Python or JavaScript, assertions about the correctness of our resources, and then run those just as part of any deployment that we happen to do. And then the third category is kind of integration tests. And so these are the ability to go and stand up a real set of infrastructure based on the code that you wrote, validate some things about that infrastructure behaving the way you want it to, like maybe hit an endpoint on the infrastructure or run your application level unit tests against that infrastructure. And then when we're done running those tests, tear it all down. And so this kind of ephemeral infrastructure testing can be really powerful because now we can really validate the full correctness of that infrastructure. Of course, it's a lot more expensive because I have to stand up real infrastructure. It's going to take a longer time. It may take tens of minutes to run a test. But there's a few things that can be really important here. So one, I can bring, I can write, if I have lots of different tests I want to run, I can often run those in parallel. So my long poll still may be tens of minutes, but I may only need to pay that long poll once and be able to parallelize everything else I do in terms of my integration testing. The second one is that, we talked about sort of the importance of components. And if I'm building infrastructure components, I can actually integration test those components as individual units without having to integration test my entire application all at once. And so, for example, with that EKS cluster component that we build, we actually have a library of 40 or 50 integration tests that we run against that on every commit we make to change that code base. And it validates that with a whole bunch of different configurations of that EKS cluster, we can stand up a cluster, the behavior of that cluster is what we expect, and then we can tear it down. And running those tests is actually reasonably cheap. It does take 30 minutes or so to run that battery of tests on commits. But the total cost of that, because the infrastructure is only stood up for a matter of minutes, we only pay cents to validate that because we don't have any long-lived infrastructure. Every one of these deployments is an ephemeral environment for that component. And this lets us gain confidence that our component behaves as we expect. And now we don't have to as heavily test that as part of our full application. We can trust that it behaves as expected, and more focus on testing of the application behavior that we've got when we combine that in. Okay, so in this example down here is just a very simple example of kind of that unit test category. It just shows that I can write really effectively as a standard Python unit test in this case. So I can say, I can put an annotation. This is a plumie.runtime.test, and now inside that test, I can just go and grab some things like I can grab my server URN and tags, and I can say here's some assertions I want to run against those. So I can assert that the tags is not none and that name is one of the tags. So this is some logic I might want to inject in and just run in tests. This will just validate that if I ever create an instance in my code, it must have a name tag, and so I can get that feedback immediately as I'm going. All right. So before I dive into kind of the last demo section, curious if folks have any other questions on testing or components or Kubernetes or Pulumi generally. I'll give just 30 seconds in case anyone throws something up. All right, great. Well, let's keep going then. So what I'm going to do now, in this one, we don't have a workshop kind of written up for this, but folks can feel free to follow along with kind of what I'm going to show on screen here. I'm going to show just a couple of things to kind of take this infrastructure and kind of test it. So let me just bring up. Let's go to one of yours here. Okay, so this is all today in a main.py file. But to really test it, what I want to do is kind of split this up a little bit and organize my code a bit better. This is something, of course, since we're using a kind of a programming language here, we're capable of sort of reorganizing and sort of organizing our code in the way that we want. So let me put this in an app.py file. Oops. Oh, because I already have an app.py file. Let me go ahead and just take all of this code I have here, almost all the code, and move it into my app.py file. This is just the same code we had before. I'm just going to put that in app.py. And then here, instead of all of this, just leave the imports even though I won't use them. We're just going to import app. Okay, so I've not really made any changes. I've just sort of said I'm going to move this code around. So if I go ahead and try and deploy this, we should see, if I've done this correctly, that, oops. Yes, so what I need to do is app.service, app.service. There we go. Yep. So now these services are defined within app. So let me go ahead and do that. Okay, so 5 unchanged. So I reorganized my code, but it still does the same thing. I just put that in a different file. So now what I want to do is instead of running this entry point, I want to run some tests that also use what's in this app file, but just test its behavior without actually kind of deploying some infrastructure. So I'll go ahead and take this, this test.py file, and I'll just go ahead and write this part from scratch. So the first thing is I want to import unit test and import Pulumi. So this is the standard Python unit testing framework and the Bloomie API. So what I can do is sort of create a class myMocks, which is going to be my way of mocking Pulumi's resource providers. And so I can just create a class that inherits from Plumie.runtime.mocks. And there's 2 APIs I have to implement. So the first is new resource, which is the mock that's going to be called whenever I try to create a resource. So instead of me going out to AWS and actually creating it, or out to Kubernetes to create it, we're going to go ahead and create it just with a fake name. So its ID is going to be whatever the name of the resource was plus this ID thing. And the outputs are going to be just the same thing as the inputs. So you can see here the constructor says this function should return the physical identifier and the outputs for the resource being constructed. So that's what we're doing here, physical identifier and the outputs. So as we need to mock more and more functionality, we can go ahead and add special cases in here that handle other kinds of resources. The other one we need to do is this call API. So I won't actually be using that this time, but if I made some invoke to look something up, for example, that would hit this call endpoint. And so instead of me looking that up in AWS, I would just mock out what I want to. Okay, so now we've done that, we can use those mocks. And so we can tell Pulumi, instead of using the default connection you have to the cloud provider, just go ahead and use these mocks to run your application. And now finally, once I've done that, I can import my application code. And so now that when I do this import, it will use these mocks instead of using what's built into Bloomie. And then finally, I can create a unit test. So I can create a testing class that inherits from this. So I can use that Plumie runtime.test. Now I can write an actual test itself. And so for this example, it's going to write a very simple one. What it's going to do is it's going to take the, this is going to be app.deployment, I think. Oops. What is it called? It's called app deployment. Okay. So it's going to take this app.appdeployment. It's going to take the metadata of that and get its namespace. And then it's going to say that that namespace should be equal to Luke Hoban. So I'm going to validate that I correctly set Luke Hoban as the example there. And so, okay, so now I've written a little unit test against this that can run without me deploying any infrastructure. So now I can just run this with, I think it's, unit test. Oops. Yes. Okay. So, So what I tried to do here is I tried to run this unit test with just these simple mocks that I've written here. And we see that we actually get an error, and it's actually an error within the implementation of stack reference here, so stack reference.py. And the reason for that is that the stack reference itself, if you recall, if I do Plumie stack here, the stack reference itself was a resource. And so it's a special kind of resource that is in the Plumie namespace. And so because I'm not actually connected to an engine, this resource is not going to get referenced. And so we actually need to mock out that stack reference so that we can run our code without having to connect to a Plumie backend service or anything like that. And so to do that, we'll actually just mock that. And so let me just show you what it looks like to add a real mock as well here. So what we'll do here is we'll say if the type of the resource is Plumie stack reference, like we saw down there, then I want to use a different set of outputs. So I want to pass all the inputs, but I also want to pass an output called outputs, coincidentally enough. And that output should have a kube config, and that kube config will be this cluster over here. Okay, so now when I run this, my stack reference will have outputs, even in my unit test. And so I'll be able to get those outputs and pull the kube config off and set up all that stuff. And so if I run Python at unit test, okay, there we go. So slightly anticlimactic, but we got a test, passing test run. And if I did, you know, something like this, and just reran it. Oh, I guess it's not working correctly. Well, I won't go look into that now, but we ran one unit test, so we did run the unit test in this case, and I will go look into why that wasn't running correctly when I made that update there. But the other key thing is that this is running just in about 1 second, so we're able to get very quick feedback on the correctness of our infrastructure. Just by running these tests, we can run this in a watcher process or what have you. And so that's one example of testing with Pulumi with unit tests. Ultimately, once we've got a little bit of this mocking framework set up, we can really easily just add tests with a few lines of code here to validate more and more criteria about the correctness of our software. Okay. So the one last thing I just want to touch on, didn't have a chance to demo this, but I kind of talked about how testing is particularly useful along with components. And so the other thing we could consider doing here with this is, you know, there's a lot of boilerplate here, right? We've got this deployment and this service, and there's a lot of just, you know, Kubernetes has a lot of boilerplate things. And so what we could imagine doing is just creating our own component, right? So we could create our own component called like a service deployment, for example, which packages up both of these resources into a new component and lets me just specify effectively what namespace I want to put it into, what image I want to deploy, optionally how many replicas I want, and what ports to use. And with those 5 pieces of information, that's all I need to sort of set up a standard configuration here. And so I could actually introduce that component. I could validate that component's correctness independently of this specific usage of the component. And then I could just create and use that component within my application itself and have confidence. So that ability to kind of refactor things into components, test those components, validate them, just standard kind of software engineering best practices, but really easy to apply. Okay, so with that, kind of wrapped up on demos. I see a couple of questions here, so let me answer those, and then we'll go into a very quick kind of wrap up for the session. So the question was, you know, it's still not clear whether I can achieve the same as TerraTest with Pulumi. So yeah, TerraTest is a tool that's used for Terraform and for actually a number of other kind of infrastructure deployment things. I believe TerraTest itself does not yet support Pulumi. I think we're actually talking to some of the folks who build TerraTest about potentially adding Pulumi support directly into TerraTest. But at the same time, there's that integration testing category that I talked about on the slide. Is really the same category as what TerraTest does. TerraTest lets you stand up a set of infrastructure, run validation against it, and tear it down. It offers a number of other capabilities, but that's roughly kind of the main way it gets used. And we do have frameworks like that for Pulumi. We ourselves have a Go-based integration test similar to TerraTest, but that scripts kind of Pulumi deployments. We've seen a number of you know, folks in the Pulumi community build tools as well. There's a tool called Pitfall in the Python world that does the same kind of thing. We've seen folks build internally build their own test frameworks, you know, that work with the internal infrastructure they have to deploy infrastructure in the same way that TerraTest does. So very much possible to do that. That's sort of this integration testing category. We find that to be, you know, one of probably the most valuable kind of things to do with integration testing. But if you also want to augment that with really fast tests and things we use in unit testing, that's a super valuable way to get upfront validation of the way that you do your testing. Okay, next question I see, is there any way of developing locally without the development environment having to be in the cloud? So yeah, so this is actually part of what's great about the unit testing and the mocks that we just showed here is I can do that completely independently from touching my cloud provider. And so I can really quickly develop and test there. Now, of course, there's a lot I don't get, right? If I'm not actually touching my cloud provider, a lot of the correctness of my application is not being validated. Whether or not my instance is actually going to run with the configuration I specified, I won't really know for sure until I ask AWS to create it. And so you do need, if you're building cloud infrastructure, you do need to ultimately be able to deploy and validate against the cloud itself. But that unit testing capability lets you do a lot of the inner loop of the development without having to touch the cloud provider, and so you can make more progress without that. I see the follow-up question on the kind of testing framework. So is the testing framework you mentioned available in other supported programming languages? So something we definitely want to go and expand out some of the sort of integration testing frameworks that we provide as well. The unit testing that I mentioned here is available, I think, in all the languages we support. There's actually a great guide. So if I go to the Plumie docs, got a testing guide here. And so this has, description of these different categories, the trade-offs, and kind of how you work with these things. And then it does have examples for, unit testing in each of these languages, and then examples for integration testing with Go. That's the only language we support that framework in right now. But you could use it with programs written in any language. And then property testing in TypeScript. Working to expand out the matrix of where these things are supported. But already the unit testing you can do in any of the languages there. All right, and then one last question I see here is, will your PR for multi-language Plumie component libraries allow languages transpiled to JS to be used for coding infrastructure with Plumie? So I think it's just referring to some ongoing work we're doing to kind of allow components to be written in one language, but then get used from other languages. So things like that EKS component I showed, that's a component that's today available for folks using Plumie with TypeScript. We really want people to be able to use that from Python and C# and Go as well. So we're working on the infrastructure to do that. We definitely will enable any Plumie library to ultimately be used by any language that works with Plumie, and that's something that's kind of in progress right now. In terms of the specific question about languages transpiled to JavaScript, those actually can already be used. So any language you can transpile to JavaScript, you can run with Plumie because Plumie has support for Node.js. And so anything that you can run on Node.js, which these days is effectively anything, you can already do with Plumie. Now, that often doesn't provide the best experience for using those languages. But if there is a compiler for the language you like and you know how to use that integrated with Node.js, you can use that with Plumie. Today. So definitely encourage folks to check that out if that's the path they want to go down. All right, let me switch back into slides and we'll wrap things up. Okay, so we covered a lot of different topics today, from kind of components to multi-stack architectures to testing and Kubernetes. And so there's a lot more though that we haven't been able to cover here yet. And so if you're interested in any of these topics, I encourage you to go. There's great documentation on these in the Plumie website. You can go check that out. And tons and tons and tons of examples out there for all the different pieces here that you can use to kind of get a look at how Plumie works with various scenarios you might be interested in working with. So just a couple of those I'll call out in case they pique your interest as something to follow up on. One is secrets. So we didn't really talk much about secrets here. We talked about config and the ability to configure inputs to my stack in the last session. But secrets are sort of an extension of configuration where we can say that some of our configuration is secret. And so it'll actually be encrypted. It won't be stored in plain text in my configuration. And when I actually do my deployment, it will always be serialized in the Plumie state file, and in any place where the state file gets sent, it'll always be serialized in an encrypted form. And so you can then plug in your own encryption backends. You can use the Plumie service, or you can work with KMS or Key Vault or whatever it is you want to work with to do your encryption. And so this gives you sort of end-to-end encryption where you don't have to trust Pulumi, for example. You can have any secrets you want be encrypted with keys that you control. And then the only time they'll be decrypted is in memory inside the Plumie deployment that's running within your environment. So you get complete control over that. So really interesting support there. Something that secrets are a very important part of any infrastructure deployments. And so definitely encourage folks to kind of look at those if they're interested. The second one is importing and adopting existing infrastructure. So we know that many teams today already have existing infrastructure, whether it was deployed with point and click or CloudFormation or Terraform, what have you. Plumie has great support for adopting that infrastructure or coexisting with that infrastructure. And so, you can definitely go and, if you have existing infrastructure, that should not be a barrier in any sense to trying out and using Plumie. Plumie offers a bunch of different ways to sort of work with that existing infrastructure and even move it over when you're ready to. That includes actually being able to, if you have stuff in Terraform, it's actually very easy to convert Terraform over to Plumie. So we have a tool called TF to Plumie. So if you do have some existing Terraform stuff and are looking for kind of the real programming languages, some of these software engineering benefits, we do have some tools to help with that. I mentioned policy as code very briefly there, but if you're looking for sort of enforcing compliance and security oriented policies, Bloomie has a whole other sort of capability around how we author and write these policies in a really rich way. So a whole other thing to check out. And finally, we focused really on kind of the development process here, just in demoing kind of the developer loop. But when you're taking the stuff into production and trying to do this in a more robust way, you're almost certainly going to be moving your deployments into sort of a CI/CD kind of pipeline, potentially triggered by GitOps flows. And Plumie has great support for that. There's guides on the website there for integration with a dozen or so different CI/CD providers. And in general, we see that pretty much everyone, once they hit a certain level of maturity with Pulumi and are really starting to move into using it in production, is going to tend them to move into a CI/CD system. So definitely encourage checking that out. And finally, we touched on two providers, AWS and Kubernetes, but there are 50 or so other providers that are available with Plumie today. So no matter what you're working with, there probably is a provider for it out there. And so Plumie, one of the great things about Plumie is you don't have to build just for one platform. You can do AWS plus Cloudflare plus Kubernetes plus New Relic plus GitHub. You can do all these things together and coordinate your deployments across all those things. So that's another thing to go check out as well, to see if the platforms that you work with are available in Plumie. And if they're not, drop us a note and let us know, and we'll see what we can do about that. All right, so just to wrap up, and I'll answer Q&A until we're done after this. But just to wrap up, our docs are a great place to go to learn about any of this. Plumie.com/docs. You can follow us on @Bloomie Corp on Twitter, or me @Luke Hoban on Twitter. We have great examples in github.com/Plumie examples for, I think there's 120 or so examples now. So a lot of different things covered there if you're looking for getting started on something. And of course, our Slack channel got a great community of folks helping people to get started and answer questions around Pulumi. So join us at slack.plumie.com to ask any questions you have. Great, so that's it for me today. I'll answer questions while we have them, but thank you everyone for coming, and we'll see you next time. Bye. Okay, so there's a question off topic, but any updates on supporting the ability to use the Plumie CLI within custom scripts? So I mean, today we definitely support this in the sense that you can shell out to Pulumi. We have --JSON commands, flags for many of the commands, so you can write scripts that use Pulumi up. In fact, many of the most heavy users of Pulumi that we talk to are actually scripting this in various ways, either scripting it into their CI/CD workflow, or scripting it into sort of programmatic tooling that they've got to provision and deprovision infrastructure. It's very common to build scripts around Pulumi. Today, that's done by invoking the CLI, but I think the issue that's referenced here, I suspect, is one where we're looking at whether we can expose that in a more API-driven way. So expose APIs in JavaScript and Python and Go, which let you coordinate the Plumie engine directly without having to shell out to a CLI command. So something we're looking heavily at. We've seen this use case come up a ton. Very excited about kind of what we can do there, and really aligned with the ability to kind of use your programming languages for your infrastructure is the ability to programmatically control the deployment workflows of your infrastructure as well. So definitely something we're thinking a lot about. The next question, how to advocate for adding a new provider that already exists in Terraform but not yet in Plumie. So I'd say the biggest thing, drop on the Slack channel, and there's a hash contribute channel in there. Drop a note in there saying, hey, here's a provider that I use in Terraform. Would love to have this available in Plumie as well. And someone from the team, I'm sure, will jump on and kind of give you guidance on how you could build that. It's actually very easy to do that. We have some Bootstrap repos that sort of you can just clone and update a few things. But then once you have something working, we tend to be able to sort of take that over and publish it and test it and that kind of thing, so that we can make it available to all Pulumi users as well. So yeah, definitely drop in there, let us know, and feel free, as with anything, to open up an issue in the open source project and let other folks upvote on it. That will give us a great sense of kind of what the things are that the community at large thinks are most important here. But it's also quite possible we already have it, because we have quite a few of these providers now. So great. Great. And then the last question I see here is, will this recorded webinar be posted to YouTube? And yes, it will. This should be up on YouTube soon. So feel free to forward this on to other folks who may have missed this. And of course, we have other webinars where we'll be covering some of the same material as well as some new material coming up over the coming weeks. And so feel free to jump into plumie.com/webinars to check out the upcoming webinars we've got on deck. All right. Well, thanks again, everyone, for joining us. Have a great rest of your day, and we'll talk to you soon. Thanks. Bye.